All right. Hello, everyone. Welcome to Q&A with Tech Services. I'm Olivia Radcliffe, and I am here with the incomparable Dr. Gustavo Varca. Gustavo, go for it. Give your intro.
Hello, everybody. I'm Dr. V. I'm the new applications manager at eBeam, and I guess we have an interesting topic to talk about today.
You say that every single time, but yeah, we do. We always have interesting topics, right?
Right.
So today we are going to actually talk a little bit about conversion from other sterilization methods like ETO or ethylene oxide and like gamma to e-beam processing. Because I know, Gustavo, you've been saying that you've been getting a ton of inquiries lately, which we can get into the reasons why if you want to. But kind of wanted to go through, how does someone, when they're looking to make a conversion or thinking about making a conversion, how do they know if their product is a good fit, if it's going to be an easy conversion, or if it's something that is really not going to be a good fit for e-beam?
It's a very interesting question and very detailed. I hope I will try to give it a good answer for that. So ideally, the ideal fit, let me word it this way. The ideal fit, the easiest conversion, is for those products that are have medium to light density. Okay, I can give you a few examples: bottles, labware, syringes, right? Pipette tips. Those are great examples of products that tend to be a direct conversion, whether from a bulk package or from a oriented packaging.
Okay. Okay.
Right. So those tend to be very straightforward. On the other hand, ethylene oxide has been the modality for products that have multiple densities, right? Because when you're doing a product that has multiple densities using radiation sterilization, you really got to pick a point, right? So to make sure the whole product is getting the minimum dose, some regions are going to receive a lot of those. So combinatory devices, right? Combinatory products. Combination products sometimes are trickier. So I'm not saying they can't be done. I'm just saying they require a better look at the product and its components to make sure they will tolerate the radiation doses, right? So that's an important element to look at. When I look at gamma, right, when we look at another radiation modality, right, like gamma radiation from cobalt-60, what we see is heavier packages, like really dense material, right? Because gamma, they're photons. They penetrate matter beautifully. They're different than electrons. Electrons have mass. As they penetrate into matter, they attenuate. So we got to deliver more dose, and you have a minimum max, wider minimum max ratio, right? When you compare to gamma. So when a person is looking to convert from gamma, it's important to look at those things, right? Because when you talk about electron beam radiation, you are talking about a technology that packaging orientation matters, right? So the product being homogeneously and being oriented inside the container, the package, helps a lot for electron beam. And our team here will evaluate what's the best way to process it. Please forgive me for any Brazilish I've thrown out there. Sometimes I lack a few words to be able to explain what I would like in a known scientific or known doctor way, which I don't. That's what I'm trying to get to. So my point being, packaging is the key. How we present the product to the beam is the key, right? So yeah, I guess I tried. I tried.
No, that's good. All right. So what are some products or some configurations that are not a good fit for conversion, where if someone wants to convert, either it's like an absolute no, like this is not the best option, or it'd be something that needs to be repackaged, or you'd have to think about it in a different way?
So I guess the easy way to answer this question is of course there are multiple scenarios like we can think of, but the ideal scenario is shorter boxes are better when the products are dense, making sure that we're able to deliver the dose throughout the packaging configuration, right, the case configuration, and we're exposing units individually to the beam inside a box. It's the best scenario, though,
What do you mean by short?
I mean, 10 inches, 6 inches, as opposed to 30 inch to a box that holds 10 layers of product. So if I'm beaming top to bottom, my beam has to go through 10 units at a time. That actually requires more dose, right? And will lead to a higher dose, a wider dose distribution. So short stack product, like 3 to 4, 2, that's usually ideal, right? If you send for example, a box of micro pipette tips, right, in cases, and you send 10 on top of the other, it will be very unlikely that we're going to be able to get through it. So we're going to try to look for the region with the lowest density, right, by rotating the box.
So, okay, you said short configuration for dense products. So you've clarified what short is. What is dense to you? How do you
So
classify something as dense?
Matto is dense, right? So Matto is dense. There
I
are
just tried
some
really hard not to roll my eyes. Sorry. Continue.
um, for example, there are products where they're not completely filled, like not hard plastics, for example, not a brick of plastic, right? So a bottle, for instance, a bottle is a great example. Whether it's a small flask or an iron vial, that kind of thing, those are great because there's lots of air in it and you can penetrate. Now, if it's a completely filled brick, like a brick, it's a lot more complicated to get through it, right? You probably won't be able to do it. So there is a number we throw out there, and I'm going to put in the comments or in our blog after this. I will put a little table, I promise, where ideal densities can be found. Okay, for that conversion. It would be hard to
Absolutely.
answer.
Okay, so for kind of low to medium density products that aren't super densely packed in their oriented packaging, that's
Yes.
a pretty easy conversion,
Yes, they tend to be very easy to be converted.
but not like 50 pounds of flour or 20-liter gallons of water or something like
Yes, yes, yes. That's that, of course. We could even eventually get through it, but it's too hard. You know, it will be too complicated to deliver the dose throughout the whole product and making sure it's receiving a good dose. So what that will do, if we are actually able to penetrate the product, is will lead to a higher max. So the product
that.
will
Mm-hmm.
need to tolerate the higher dose, right? And that's the challenge with combination products, because you have some regions that will require, they will attenuate a lot of those. So you will need to deliver more dose to reach those
Mm-hmm.
areas. But when you have like a little tube on the side of the product that's really, really small, that part's going to get a lot of dose. And that's where you start to see some detrimental effects, right?
Okay.
Some of those we're able to overcome, some of those, unfortunately, cannot be overcome.
So a combination product or something that has really dense areas, but also areas that are not quite as dense, but have a very tight dose range with your existing, if it's coming from gamma or something, that might be something that could be questionable. You might need to go to the drawing board again about packaging or get creative with how it's being processed, or
Yes.
maybe extend that range a little bit.
Yes, and our team is ready to help with that.
Mm-hmm.
So if anybody listening to this Q&A that we're doing has any concerns about the project, about the product, our team is trained to take a look at it, evaluate, try to identify the densities right along the product and the components that are sensitive
Mm-hmm.
to it. And we're ready to give an honest opinion. Hey, this is really not ideal for electron beam. You should really stick to the other modality. Or no, this is a great fit. Or you know what? It's not the greatest fit, but we can find a way of working. And I think we've addressed this in previous Q&As, Olivia, where we talked about a product that we process. It's on a metal case. We
Mm-hmm.
talked about 20-pound cases of flour. But if they are rightly packaged, it works, right? And there's also something special, we can do here to deal with combination products and make them work, which is the layout processing,
Mm-hmm.
right? Talking a little bit about that. The nature of our conveyors enable us to use gravity to keep our product steady in the cart, and we're able to expose the combination products individually
Mm-hmm.
in the cart. That way we call it layout processing because it's basically a layout process. and we're able to deliver the dose for products that require, they have a really tiny dose range, or they're sensitive. So we're able to tune the dose better when we process it that way. So we have options to overcome that, and our team is ready to be able to identify when they are one of those.
Perfect. All right. So we know what's a hard configuration to validate, what's maybe questionable, but potentially doable. And then if you have something like boxes of bottles or other labware like that, that's a pretty easy conversion, right?
Yes. And those, you would be surprised by how tall they can be, right? Because
Yeah.
they're right. And yeah, those are like really straightforward examples, right?
Perfect. Anything else you want to say on the subject?
No, I guess my final comment is, if you're in doubt whether e-beam is the right modality for you, just give our team a call, and we'll be happy to evaluate the product and give you some honest feedback, whether it's worth pursuing path forward with electron beam or looking into another modality. And even though we're even a provider of electron beam technology, we're not against any other modality. We're very well aware of the importance of sterilized medical devices for humankind. So we believe in the future of all the sterilization modalities. We are specialized in one. If you need it, just give us a call.
All right, perfect. Well, thank you, Gustavo, and thank you all for listening in, watching. If you have any questions or you want to book a call with Gustavo, kind of go through your products, I will put a link below the video, or you can find the contact form at ebeamservices.com. All right, we'll see you soon.